Okay, so yes, the last class we have seen about TM waves. Today we'll continue with TE waves of rectangular waveguide, which is bounded on all four sides. So here you can see in TE waves, EM waves of which there is no component of E in the direction of propagation, that is Ez is 0, and expression of TE waves are derived in the same manner as we have done for TM waves. So the process is same, you can go through these calculations, I am not repeating. Here obviously there for modes there are two values m and n. This point to be noted. For any particular combination of m and n will constitute one mode. Like when we go for T10, which is the most popular mode, then 10 means one half cycle variation along x and no variation along y. So for T10 mode you can see along a, you see along this direction there is one half cycle variation, and along b it is constant. So that is why it is TE10 mode. It is TE10 mode. Okay, now propagation parameter of T and TM waves in rectangular waveguide, the analysis logic is the same. Here you can see the propagation constant. Now both m and n has come into picture, unlike parallel plate where there was only one parameter m. So here then the entire process is similar. For different values of mn you will have different propagation constant, attenuation constant and phase constant. And again, if there is minus sign here, then naturally three cases will arise when this part is greater than this, smaller or equal. So accordingly you will have evanescent mode, cutoff mode, propagating mode and so on. So accordingly we can calculate the cutoff frequency. Here you can see this cutoff frequency is again dependent on broad wall dimension, narrow wall dimension and which mode you are working in. That will decide the cutoff frequency. To be remembered is that cutoff frequency means if frequency greater than cutoff, then only it will propagate, wave will propagate, and just the opposite for wavelength. So here is the cutoff wavelength. This is the guided wavelength. Rest all process is same. Here difference is this time m and n both will come into picture. So these are some of the summary of the formulas which we have to remember. They are very important for solving numericals. And what is a dominant mode? Among different modes, the mode which has lowest cutoff frequency, that is the dominant mode of propagation. So like the cutoff frequency for dominant mode is V by 2A. A is the broad wall dimension. Provided A is greater than B, then this TE10 mode is the dominant mode, and corresponding to that cutoff wavelength for dominant mode is this. To recall again, dominant mode is the mode which has least cutoff frequency or the lowest cutoff frequency. So for TE10 mode, again you have the cutoff wavelength lambda, and from there other parameters like group and phase velocity can be calculated. Then we have this, you can see the excitation methods for different TE and TM waves or modes. Like you can see excitation method for TE10 mode by a probe. You can see one probe, there is one central conductor is there, means it is acting like a probe, or by a loop. You can see one loop is here. So probe is E field detector, loop is H field detector, because when a H field crosses the loop, then it current gets flow through it. So that is the thing, loop is H field detector. So this is probe and this is your loop, TM11 mode. These are the different methods of excitation. These are some of the numericals, you can go through it. The next class we will do waveguide resonators.